All right, let's go ahead and get started. A couple things I want to do today. I want to review arithmetic sequences. I'll go over, it looks like only one question from the homework. And then after that, we'll start to cover geometric sequences, their nth term, and their sums. Okay, so we'll only get about halfway through this lesson. So we're actually going to continue geometric sequences on to the next class. But you do have homework tonight. And I'm going to hold off from telling you that just yet, um, just so people focus on this first. All right. So last class, we went over arithmetic sequences. All right. And an arithmetic sequence is a sequence whose basically we're just adding a certain term over and over again. Um, in order to get the nth term of an arithmetic sequence, we need something called the common difference. All right, and the common difference is just that same number we're adding over and over again, denoted as d. All right, the nth term of this sequence then is the first term plus n minus 1 times the common difference. And then the sum of a finite arithmetic sequence is the number of terms we're adding together over 2 times the first term plus the nth term. And then I have a little bit of summation notation just in case anyone forgot in the bottom right. Okay. Couple things before we get to the homework question. All right. What is the final in this class? I am still undecided. I will have an answer next period, your next class. So on Thursday. Okay, and I'll define it a little bit more by then. I have a pretty good idea of what I want to do with a couple other classes, but because we're running a little bit more out of time, I still haven't decided. Okay, so you will have an answer. I just don't have one yet. All right. Um, so with all of this up on your screen, I want to do one question. Which looks like this. Okay, so this says to find the sum of the finite arithmetic sequence from 1 to 16. Okay, so we have an equation for this, and you just have to plug it in. All right, so the number of terms we have is 16, right? In order to get from 1 to 16, there are 16 terms. The first term, a1, is just 3 times 1 plus 2, which in this case is just 5. And then the 16th term, right, the nth term, is equal to 50. And then we can plug that into a calculator and get an answer. Okay, so that equation, that's the sum of the finite arithmetic sequence. Again, that's something we need to know. We need to know that and the nth term, how to find it, which I had written on the other screen. And that's a1 plus n minus 1 times the common difference. Okay, so any questions over that? All right, so today we're going over geometric sequence and series. All right, so in an arithmetic sequence, we were adding a term over and over and over again. In a geometric sequence, we're multiplying by a term over and over and over again. Okay, so a sequence is geometric if the ratios of consecutive terms are the same. Okay, so if we have the sequence A1, A2, A3, all the way up to AN and then beyond, it is considered geometric if, when we take the ratio of consecutive terms, so A2 divided by A1, A3 divided by A2, A4 divided by A5, and so on, if each of those ratios is consistent and constant, then we have a geometric sequence. And we have a geometric sequence with ratio R, which we will define as the common ratio. So where an arithmetic sequence has a common difference, a geometric sequence has a common ratio. Okay, so I'll let people kind of catch up writing if they are, and then we'll get to two examples. So the first thing that we need to be able to do is to just determine whether or not a sequence is geometric. All right, so in the two examples down below, we need to determine if they're geometric, and if they are geometric, then we need to find the common ratio. Okay, so again, in order to do that, we have to take the ratio between consecutive terms. All right, so 4 divided by 2, 8 divided by 4, 16 divided by 8, and 32 divided by 16. Okay, each of these is equal to 2, so 2 is our common ratio. So in this sequence, in order to get the next term, we just multiply the previous term by 2. And in the second sequence, again, we do the same thing. In order to make sure it's geometric, we need to find a common ratio. So we would take 1/9 divided by -1/3, -1 over 27 divided by 1/9, 1 over 81 divided by 1 over 27, and so on. Okay, and I know fractions kind of freak people out, but in geometric sequences, if just the denominator is changing or just the numerator is changing, you know the common ratio is in either one of those. Okay, so if we just look at the bottom, the denominator, in order to get from 3 to 9, and from 9 to 27, and 27 to 81, we're multiplying by 3. Okay, so there's going to be a 3 in the denominator. And because they switch signs, we know we're multiplying by a negative, and we're left with -1/3. Okay, if that didn't make sense, we can just do it in the same way that we did the sequence above it. 1/9 divided by -1/3 is really equal to 1/9 times -3/1, which is negative 3/9, which is negative 1/3. Okay, so we could check every one of those. I'm telling you right now that it is geometric, so they're all consistent. But I want to pause there for a second. Are there any questions over those two examples? So again, just like arithmetic sequences, um, we can find the nth term of a geometric sequence using a general rule. Okay, and that general rule is that the nth term is always going to be equal to the first term times the common ratio to the power of n minus 1. Okay, again, that's an equation that we should know. So in our first example from up above, that 2, 4, 8, 16, 32, we have a common ratio, and we could probably extend this just using that, right? So it would continue as 64, 128, but that doesn't give us a general rule. We can find a general rule, though, by using this equation. Okay, so we have a first term. We have a common ratio. And that's really all we need, right? So the nth term of this is going to be equal to 2, our first term, times our common ratio to the power of n minus 1. And that would be our answer. On the bottom example, we can do the same thing. Again, we have our first term, we have our common ratio, so we can write the nth term for this sequence. So if we do that, an will equal negative 1/3, right, our first term, times negative 1/3, our common ratio, to the power of n minus 1. Okay, so this also means, and this is like, geometric sequences are one of the most important things in probability, at least in early probability, because it often involves us just multiplying probabilities together, the same probability together. Okay, and we'll kind of explore what that looks like here in a couple of classes. But we can rewrite this first term, right? So this 2, 4, 8, 16, 32 sequence as a1 times a1 times r, or plus a1 is the first term, a1 times r is the second term, a1 times r squared is the third, a1 times r cubed is the fourth, and so on. And we can write any sequence, any geometric sequence just like that. We can split it up as the first term times something to some power. Okay, so again, I want to pause here. Are there any questions over anything I said on this screen? So let's go over a couple examples of this. This is not exactly what your homework is going to look like, but it's something that is very important to understand this a little bit further. Okay, so our first example, the first 5 terms of the geometric sequence, we want to write the first 5 terms of the geometric sequence, whose first term is 3 and whose common ratio is 2. So we can use what we know about geometric sequences in order to find these terms. Okay, so we have common ratio 2 and whose first term is 1. So really all we're doing, 3, is we're multiplying this first term times the common ratio a bunch of times. Okay, so the first term is 3. We multiply that by 2 in order to get the second term. Multiply that by 2 in order to get the third, the fourth, and the fifth. Again, this would be 3. This is 3 times 2. 3 times 2 squared. 3 times 2 cubed. 3 times 2 to the fourth. So that's like a basic example, just being able to get terms of a sequence. Are there any questions about that? All right, the second example, find the 12th term of the geometric sequence given below. Okay, so we're given the first term, so the bottom one would be 15 times 3 to the 12th. Kind of. So we're going to look at that real quick. We're given the first term, and really we're given the pattern. We're not given anything else. Okay, so the first thing that we need to do is we need to find the common ratio. And because we're given that it's a geometric sequence, really we just need to find the ratio between two things. So if we take the ratio between two sequential terms, we get our common ratio. And then from that, we can write the nth term. So an is equal to the first term times the common ratio to n minus 1, which is equal to 5 times 3 to the n minus 1 power. And then all we do is substitute 12. We plug that into a calculator, and we get an answer. So 3 to the power of 11 times 5, and we end up getting 885,735. So questions about that? All right, so that's finding terms of a sequence and then finding a certain term of a sequence. Now, a little bit harder than that is just given less information. I thought the first term in a sequence was A0, not A1. It kind of depends, okay? So if we scroll up, our sequence, again, we're only given the first term. That A0 is a little bit misleading sometimes. We can still write the 0 term of the sequence by just plugging in 0 into n. So instead of 1, right, which just gives us 5, we plug in 0, which would give us, I think, yeah, well, it's, again, when we get to the 0 term, we will, like, you'll see the difference, okay? So on your homework, if it starts at 0, you will start at 0. It's a little bit confusing to explain. Don't worry about that right this second. Okay, but there is a difference between the 0 term and the first term, and the sum of a sequence is one that'll matter, which we'll get there here in a second. Okay, but again, let's move to a little bit of harder example of the nth term for now. Okay, so in this example, the fourth term is 125, the 10th term is 125 over 64, and we want to find the 14th term. So we're not given a sequence of numbers, we're not given the first term, and we're not given a ratio. Okay, so in order to start this, let's just label what we have. We have the fourth term, that's 125. We have the 10th term, which is 125 over 64. And we want to find the 14th term. Now, in a geometric sequence, the most important thing that you can know is the common ratio. So we also need to find that. And we can use what we know about geometric sequences in order to find the rule, and then in order to find the 14th term. Okay, so if we just look kind of on a number line, if we have the fourth term here and the 10th term here, in order to get from the fourth term to the 10th term, we have to multiply by our common ratio 6 different times. Okay, so we can write a rule from that. We don't necessarily need the first term in this case. And this, I think, kind of answers the question about A0 versus A1. Okay, we can make A4 our first term. So we can rewrite this as A10 is equal to our new first term, A4, times our common ratio to the 6th power. Okay, and I want to stop there real quick. Are there any questions about what I just said? Okay, so again, we have to multiply by our common ratio 6 times to get from our 4th term to our 10th term. That's really what this equation is saying. And we got there by kind of looking at a number line and figuring out how many terms there are from A4 to A10. Okay, then we can substitute in what we know. So we know the 10th term is 125 over 64. We know the 4th term is 125. And we know we have to multiply our common ratio 6 times together in order to get from the 4th to the 10th. Okay, and then we just solve for r to the 6th. So if we divide by 125 on both sides, we end up getting 1/64th is equal to r to the 6th. And then we can solve this in a bunch of different ways. Okay, so you could take log base 6 of both sides. You could take the 6th root of 1 over 64. Or if you know your powers of 2 really well, you know that 2 to the 6th is 64. So r, in this case, must equal 2, but in the denominator. So 1/2 to the power of 6 is going to equal 1 over 64. And that part requires a little bit of practice. Okay, so you might not know that right off the bat. But if you know 2 times 2 is 4, times 2 is 8, all the way up to 64, you can kind of get there. And because 64 here is in the denominator, the 2 must also be in the denominator. Okay, so now we have our common ratio and a couple of terms. So we can start to write our rule for A14. So again, keep in mind, we don't necessarily need the first term in a geometric sequence. So in order to get from one of our terms, let's use A10 in this case, to A14, we have to multiply our common ratio together 4 different times. And then we can substitute in what we know. Then we can plug that into a calculator and get an answer. And if you take that answer and hit math and frac, you get 125 over 1024. Okay, again, I want to stop for just a second. Are there any questions over anything I did on this screen? Again, the more specific the question, the better. Simply not getting it that's not going to help me. All right. So the last thing we need to go over is the sum of a finite geometric sequence, and this will end up being your actual homework. Okay. So the sum of a finite geometric sequence of a geometric sequence is given by the equation right here. Okay. So the sum from I equals 1 all the way up to n of a geometric sequence is the first term times 1 minus the ratio to the power of n over 1 minus the ratio. Okay, again, this is an equation that we need to know. So your homework will give you something that looks like this. And you will need to find the sum. In order to do that, we need to interpret it just a little bit, and then we need to plug it into the boxed equation just above it. Okay. So we need our first term. So if we just plug 1 into the sequence, we'll get our first term. So our first term here is just 4. And I want to just highlight something real quick. Your first term isn't necessarily always a 1. It's whatever this index starts at. Okay, so if that was I is equal to 3, our first term would really be a 3. Okay, in this case, it's just it is the first term in the sequence. So you just plug in 1. All right. After we find the first term, then we just plug in everything we know. And I guess that really we can find our common ratio first. So our common ratio is 0.3. And then we can plug in all those numbers. So we have A1, we have R. So our sum of the 12 terms is going to be A1 times 1 minus our ratio to the power of the number of terms we're actually summing. So in this case, it's 12. divided by 1 minus the ratio. Again, this number right here isn't necessarily the top of the index. It is the number of terms you're summing together. So again, everything could change when that lower limit is a different number. And when we plug in all of this to a calculator, you get 5.7. Again, I want to stop there for a second. Are there any questions over this example? Is S12 your answer? No. This the 5 point what S12 is actually equal to is your answer. Right? In this case, it's 5.7. And your homework will tell you what to round to. Okay, so I rounded this to the nearest tenth. Okay, so this is what I wanted to cover. Again, your homework mostly involves this. So if you don't 100% understand this example, this is like a harder example. So if you don't 100% understand that, that's okay. But we do need to know what a geometric sequence is and kind of what it implies about a lot of things. Okay, so your homework is W9 and W12, right? W9 is just distinguishing arithmetic versus geometric. And then W12 is like this example. Okay, so I'm going to leave this open for the next minute or so. After that, I will be on Teams. But if you have any general questions, now would be a great time to answer. If you have a little bit more specific questions, Teams would be the place to ask. Okay, so again, I'll leave this open. Any questions you have, let me know. All right, so I will close this. Again, if you have further questions, I will see you on Teams.